Hello everyone, welcome back. Now let's try to just do a few examples regarding the manometers. First of all, example 1-8. The pressure of the two pipes in the gas in the two pipes, okay, is measured by mercury. So express these pressures below. So we have two cases over here. One is on the left hand side. You'll see I draw that something like that. So based on your instinct, you will think that the pressure acting by the atmosphere, right, is actually higher than the pressure that is acted on by the gas. Simply because the level of mercury is lower at the atmospheric side. So this atmosphere is pushing harder than the gas. So how do you quantify that? You can see that this is a 30 mm, and just in our previous video, we say that the pressure of the gas, because this is a gas, the pressure difference that is existing here, right, is actually quite small compared to the pressure values at the mercury. So we can say that the pressure at the gas is actually the pressure about the same as this location over here. Okay, and what can you say about the pressure at this location? You go straight to the fact that the pressure at the same level of elevation is the same. So if we say this elevation over here, okay, let's mark this location A, this location B. So you can say that PA equals to PB. And PA is the pressure here, which is simply the atmospheric pressure, right? And PB, right, since it's the same, right, then it has to be equals to atmospheric pressure lah. So it is the P gas which is acting here, okay, plus this column of mercury, rho of mercury GH, which this is 30 mm. Okay, from this equation you can see that the P gas, right, the pressure of the gas is P atmosphere minus rho G 30 mm. Okay, so minus, it should remind you that it should remind you of vacuum pressure. Okay, so the pressure of the gas is in fact a vacuum pressure of 30 mm Hg gauge. Okay, so this is the answer, 30 mm Hg per vacuum. And over here, I think we should focus on the word vacuum. So over here, the pressure of the gas is higher than the atmospheric pressure. How high is it? It is also 30. So over here, instead of a vacuum, right, the pressure of the gas is equals to a gauge pressure of 30 mm Hg. Okay, because it's 30 mm Hg higher than the atmospheric pressure, so you can say that it is a gauge pressure of 30 mm Hg. That's how this pressure can be expressed. Alright, so next we go to example 1-9. Okay, referring to the example in figure 1-7, meaning to use this as an example. Okay, this figure on the previous page. Now instead you have oil. Okay, so let's try to draw this. So this is A, and this is H1. This is H2. Alright. The oil has a relative density of 0.9, so the density of oil is 0.9 of water, which will give you 900 kg per meter cube. Okay, and the density of mercury is 13.6 times. So it gives you 13,600. So H1 is 129 mm. H2 is 229 mm, but if we convert to meters, this is 0.129 meters. This is 0.229 meters. Okay, and find the static pressure at A. So find the pressure here. So how do you go about? So now this is oil, okay? The pipe here is oil. It is no longer a gas. So I cannot ignore this height contribution. Okay? Again, we all start from the same elevation. So now let's say this is elevation 1 here. This is the point 2, okay? Elevation point 2 is here. So these two pressures are the same. P1 is equals to P2. This is how you should approach the problem here. P1 is equals to P2. So what is P1? P1 is basically the pressure at here plus the height contribution by H1. Okay, so it is at PA plus. What is the height contribution like? It is like rho GH, right? But what rho? This column is a column of oil, so it is rho oil. How high is this H? H1. How about P2? P2 is literally the atmospheric pressure plus the contribution of this mercury column. Okay, so it is atmospheric pressure plus mercury column will give me mercury density and H2. Okay, in fact, so you have the terms here, and you can find PA. And the thing about this atmospheric pressure is this: if you start off with this equation, the PA that you find will have the atmospheric pressure inside, so it will be an absolute pressure. Okay, but if the question asks you for a gauge pressure of PA, then you should not include the atmospheric pressure in the first place. Alright, so let's say you are looking for absolute pressure, so PA will simply be atmospheric pressure plus, see, I shift this term over here, it will be rho GH2 minus rho GH1. This is your absolute pressure. But if you're talking about gauge pressure, this one is not inside. Your PA is simply rho oil GH1. Alright, and the answer, if you want to do a self-check, 2941.3 Pascal gauge. Okay. Next question is rather interesting, because all along one end of your manometer has always been pointing to exposed towards the atmosphere, but this time both ends of the manometer are connected to the main flow pipe. Okay, so in fact manometers not just give you the pressure related to atmosphere, it also helps compare the pressure difference between two locations along the same pipe. Alright, so this is actually a common usage for manometers to compare locations between a line. So now you have your oil of 900 kg per meter cube, and you have a density there. So how do you approach this problem? How do you start? Let's draw this again. So this is A, this is B, right? And you have a height difference, 200 mm. Let's just change it to 0.2 meters. Okay, and there is also another height. Let's just call it L. Okay, so this is where you can start, and this is mercury, this is oil. So we start off from the same elevation. I want to take at this elevation. This is 0.1. This is 0.2. So again, same thing. P1 equals to P2. So what is P1 consists of? It consists of the pressure here plus the contribution by this column plus the contribution by this column. Okay, so PA plus rho oil. This column is oil, right? G. What about the height? The height is L. Okay, and this column, the bottom column, is also rho oil. G 0.2. Okay, and this one will be the same as P2. P2 is basically the pressure at B plus these two columns, the top column and the bottom column. PB plus rho oil, GL, right? This top column over here, plus rho, this time the bottom column is not oil but mercury, G 0.2. Okay, so this is the equation. And straight away you can see that this term and this term are the same and they can be eliminated. And you can move this term to the left side, move this term to the right side. And what do you get? PA minus PB equals to rho HG G 0.2 minus rho oil G 0.2. And you take out the common terms, you get a difference in density times G times 0.2. This is the expression that you should be using. And this one you should get an answer of 24917 pascals. Okay, go ahead and try it out. Put this mercury value is 13,600 and this oil value is 900. This is 9.81. You should be able to get this answer.